We're trying to find, again, the oxidation state of a particular element, okay? The question was, I had a multiplication of 3 and really times 2 here, so I've got a lot of multiplications going on. Here I do multiply, and the reason is to solve, sorry, it's here. Here, to solve for the oxidation state, each oxygen is individually -2. But I need the sum of all the oxygens, for example, 7 times -2, to find the chromium. You know I'm not, you might notice I'm not using this 3 because I've isolated this and I say, I recognize that thing. That's the dichromate. So I'm going to ignore everything else because I'm asked about this and it's within a species that I recognize. So that's why I'm not using that 3. You could, but then you'd have to add to the equation 2 aluminum, plus 3 times all this dichromate mess. So it just gives you more math. So if there's something you recognize, you can take it out of the subscripts you're working with and just focus there. If that didn't happen, yeah, you'd have to go 6 times chromium plus 21 times oxygen -2. Yeah. You're still going to multiply by the subscript 2 for chromium, that's correct, and then divide by it here to find for each individual chromium is +6. All right. Is that kind of cool? Okay, who else has questions? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Not going to get to all. Okay, who's 1? Yes. Yes? Okay, solubility rule clarification. I'm going to go to the solubility rules right now. Where the heck are they? Here they are. Okay. What the heck is an acetate, a chlorate, etc.? So those are polyatomic anions. A chlorate is ClO3 minus. Acetate, C2H3O2. Nitrate, NO3 minus. Halide is just a halogen. Sulfate, if you need that one, is SO4 2 minus. Hydroxide, OH minus. Sulfide, S2 minus. Carbonate, CO3 2 minus. Phosphate, PO4 3 minus. Chromate, CrO4 2 minus. Is that kind of okay? All right. Who is number 3? Yes. So page 41. Okay, page 41 in my practice exam reader. I'll show that to you as soon as I find it. 41. 20, you said? Okay, this is page 41, winter 2013, part A. As a mass percentage and the density of aqueous solution are blah, blah, blah. Find the molarity. Okay, so molarity question. There's different types. This is a conversion type. I have one compound of interest, no reaction. I'm going to molarity from a percent by mass. So if you remember from class, a percent mass is actually a concentration unit. So I have to convert to molarity. So and you'll always know it's one of those when density is given. Density is classic in a percent mass conversion to molarity question. So I need to move the problem, unfortunately, so I can write down stuff. So we got HCl. What you're going to do is start with a percent by mass, which is 36. A percent by mass means grams per 100 grams. I'm going to get rid of the percent. And it's really grams of HCl, or whatever the molecule is. In this case, it's HCl. Divided by grams of solution. So that's what a percent mass is. In this case, 36%. So you're going to use the density first to convert this, and density is always the first one you're really going to use. 1.19 grams, in this case, per centimeter cubed. This is really a solution density, So that means that grams cancel that grams. Okay, because that solution and density will be in solution unless told otherwise, but pretty classic in solution. You might not have known, but you should know, that 1 centimeter cubed is 1 milliliter. So there's where the centimeters cubed get rid of. And now we're in milliliters. Now, to go to molarity, I don't want grams per milliliter, I want moles per liter. So I need to change this to liters, and that's where the milliliters are gone. My denominator is good now. My numerator is not finished yet. I need to go from grams here to moles. So I'm going to multiply, go to the next line because I'm running out of space. I just need the molar mass of HCl. I think it's 36.46 or something like that for HCl. And so that'll drop the grams. And now I have moles on the top, and this will be molarity. And I'll let you calculate that. All right, you're number 384. Yes? Yes. Yes. Let me clarify what you're saying for everybody. The question is about a binary, they're all binary, moleculars, as far as the ones that you'll learn. Let's say we had CO2. This is carbon dioxide, not monocarbon dioxide. If you had CO, this is carbon monoxide, not monocarbon monoxide. So you do not put the mono if it's the first element, but you always put the mono if it's the second element, when it's just one. Good. Number, you were 4, 5? Yes. What page? Page 25 in the practice exam reader. Okay. What number? 13. So this is winter 15. No. Oh, 14, this one. Can I save this till last? Is that okay? It's just going to take me a while. It's fun. Yeah, it's definitely fun. Okay. It's just going to take me a while. I got to save that one. Okay. You were 5, 6. I just want to kind of bust out some of the quick ones here. 6. 6 aborts. Okay, 7. What was 7? 7 aborts. Was there no 7? I thought we went up to 10. You're 7.
I found a compound in one of the homework examples.
Oh no.
And it was H2PO4. So
hold up. H2PO4.
Minus. And it said it was dihydrogen phosphate, but wouldn't that be an ionic compound, so you went with dihydrogen?
Okay. This is actually, the question is, what's this called? It's actually not an ionic compound per se. Does anybody know what we'd categorize this as? It's not an acid either. It's not neutral. To be an acid, you gotta be neutral. It's not neutral. It's just an ion. It has a charge. It's just an ion. So this is one you have to remember in your polyatomic ion list. It is called dihydrogen space. It's a polyatomic anion, specifically phosphate. Space ion. That's its name. Okay? So it's not actually in the molecular category, or, oh yes, ionic. It's not in the ionic category. It's just a polyatomic anion. Okay, again, to be an acid, it has to be neutral. That's a common mistake, not an acid. It could be acidic, but it's not in our acid naming rubric. Okay, you were 7, 8. Yes, way back there.
In a chemical equation, if you see magnesium, calcium, strontium, or barium hydroxide, would you assume that it's aqueous since they're strong bases, or would it be a solid because the solubility rules would say that hydroxides do not form, or hydroxides form precipitates?
Okay, good. So if you see one of the hydroxides, one of the group 2 hydroxides is what you're asking about, what would the state symbol be?
Yeah.
It could depend on how the problem is worded. So if it said in words, these were mixed in solution, or literally they're aqueous, then they're aqueous. If it's not listed, then it's probably best to go by the solubility rules. So then you would just punt to the solubility rules at that point.
Okay.
Again, the problem with the solubility rules is they're just rules of thumb. They're general, so they may or may not be 100% right, but that's all you got. So, hydroxides except group 2, hydroxides except group 2, the group 2 actually goes with the hydroxides as well. So they would both be soluble. So barium hydroxide, what else did he name? Strontium hydroxide, calcium hydroxide. And it's not always true. They're not always aqueous, but that's all you have to go with. So usually to clarify that one, if it's something like that, I might say in words in the question what it is, and you would have to read the question. But the hydroxides are a little messy because some are aqueous, some are not typically. Again, that's the problem with solubility. Good. You were 8?
Yeah.
9? 10? Hi 10. Hi 9. Also known as, is that North? I can't see, you're way far away.
I have a question about one question that you posted on Canvas. The alcohol test, level test one, so breathalyzer.
Unfortunately, I did not memorize. Oh, yeah, I think I know what you're talking about though.
Yeah.
That was one, I'm going to do that in class.
Okay.
Tomorrow.
Okay.
So can I hold on that one?
Sure. Yeah.
Okay. I know, it's super exciting, but you don't have to wait till tomorrow. It's only, oh no, wait, is it tomorrow class? I forgot. Whenever class is, Tuesday, yeah. 10, was there 10? Okay, what was the question you wanted me to do? What page? 25. If you want to stay for this ridiculous balancing problem, feel free. Okay, I have to kind of copy it over. I'm going to set it up. I'm probably not going to solve the whole thing because I also want to go home and watch TV. So, I'm going to write it landscape because it is pretty long. You'll notice I gave you a couple numbers. They look freaky, but it actually makes the problem easier. So let me write this out. Okay, here's all the products now. And here's some of the ones I gave you the coefficients for. Here's a couple more just for fun. Okay, here's what I would do. I mean, it's long, it looks crazy, so what I would do is just put variables in here. A, B, C, D, E, F, G. Like that. And then I would just solve it with variables. I think that's the easiest way to do it. So let's just kind of set up a couple so you can see how that works. You're just going to pick elements one at a time. So for example, let's say you pick K. So you're going to go 4A, because there's 4 Ks times whatever the coefficient A would be, plus 2B equals, now we're in the products, K, plus 2F plus G. I think that's all the Ks. Now we go to the next one, iron, same sort of thing. So you're going to put A, one there, where else is iron, equals 2D. Is there any other irons? This is nice. Now you know D, you have a little star of that one. Okay, only two variables involved. So those two are equal, that's nice. S, let's see, 6A plus C equals 3D plus 3E plus F. Okay, that one's not as awesome. C. 6 A equals, wow, where else is it coming? 36. Is that A? Did I get all the C's? This is awesome. Did I miss one? I must have missed one. That's it? Oh my gosh, that was so nice. A equals 6, thus D equals 3. Right? This is so easy. It's awesome. Look at that. Wow. Nice. Okay, CN. So then I can simplify these two equations too, by the way. Let's just do that for fun too. A is in here, so this is actually 24 plus 2b equals 2f plus g, because I just put the a in there. And this one I can put a and d in here. So 6 times a, that's 36. Plus C equals 3 times D, 9, plus 3E plus F. I can kind of subtract out, 36 minus 9, what, 27? Plus C equals 3E plus F. Okay, so a little simplification going on. N, 6A. Where the heck else is N? Here? Is that it? G. Whoa, that's awesome. So that means G is 36. Is that right? Oh my gosh. Look at this, loving it. So that simplifies both of these that I had up earlier. G is 36. Then that difference would be 12. 2B equals 2F plus 12. Or B equals F plus 6. Oh, nice. Okay. This one doesn't simplify, it looks like. Okay. All right, and what else do we got? CR, okay. 2B equals 2E. Is anywhere else? Oh my gosh. B equals E? Loving it. B equals E. So that doesn't simplify these two, it just gives me another variable to work with. Okay. I mean, I could put B here and substitute these into each other. And then get an, oh, in terms of C and F, I could do that. Okay, that sounds fun. So you could say that, I don't know if this is going to be that fun. We'll see. 27 plus C equals, B and E are equal, so that means this equals E. 3 times E, F plus 6, plus F. So this is 3F plus 18 plus F. And that's 27 plus C. Ooh, 27, that's 9 plus C equals 4F. There's another one that's kind of nice looking. Okay, is chromium, what have I not done yet? Is there anything besides oxygen? I'm kind of postponing oxygen. I haven't done hydrogen, right? Yeah, let's do hydrogen. 2C, oxygen's a tough one just because it's everywhere. 2C equals 355 times 2. What's that number? 710, right? Okay. All right, you work on that. Did I miss any? There's no more H's, right? Oh, sweet. C is 355. Look at those math savants out there. Okay? So that means I can find F. What's F? Just add 9 to that and divide it by 4. 91? Okay, I don't know what it is. Oh, somebody just randomly said 91. Oh, it is, okay. That was funny though. Okay, F is 91. That means we know what B is. It's 97. Then same as E. Wow, do I have all the letters? I have A, let's see. I've got A, I've got B, I've got C, D, E is the same as B. I've got E and F. I don't have G. Oh, I do. I'm done. Sweet. Yes? If you're given numbers? No. Does this only work if you're given these numbers? No, I was just making it more tolerable. So it actually looks scary. I like this because the fear factor here, but of these kinds of questions is the easier type of the algebra question. It'll work, still works. All right, I'm going to close up shop now. It's 10:15. Gonna go grab my camera before somebody steals it. Have a good night.